Hello everyone, February the 7th. Alright, let's get this done. I have a meeting today at 8:45 p.m. So, gotta do this fast. Not to just do this right now so that I can deal with the other thing later. Alright, give an integer n, return the least number of perfect square numbers that sum to n. The least number of perfect squares. Perfect square is integer. Okay, these are perfect squares. The least number of perfect squares that sum up to this value. I mean, the max number is just 1, right? And because it's 10,000, right? N is 10,000, so the perfect square cannot be more than 100, right? It's at most 100. So we want to find out the least number of perfect squares and add up to it. So can take a look at this. We have 1, right? 4, 9, 16, 25, whatever. And given a 12, if you go greedy, you say I do 9. And then you have 3 left. Then you require 3. Then you get 4. I'm taking care of the umbrella. I'm doing LeetCode. How was it?
Fine.
It's so cute. All right, so if we start with 12, yeah, how do you know? Maybe this is DP, maybe it's DP. Well, first of all, we're gonna get a list of all perfect squares, and then what do? We can say what is the least to get to 12. So we can say the least to get to 11, right? And then because the least to get to 11, we can say 11 plus 1, right? Or we can say the least to get to 8, because 8 plus 4, right? The least to get to 9, and least to get, so it'll be 3 plus 9. So we have the least to get to all these values, right? And from there, we're going to do the same thing. So the total runtime will be 10 to the 4th, because that's the total number, times the entire thing. So it's going to be a DP array like this, right? We know to get to 1, 0 is nothing. And to get to 1, we have one way, right? To get to 2, we just go through this, right? And then to try to find the minimum, so we have, I think 2 is almost like 2. To get to 3 is probably 3. To get to 4 is 1, because each one, right? Each one, we need to go, to start from here, we minus this, right? So 1, so we'll be like 4, right? And this is 4, that's actually 1. 0 shall be 1, right? And then 9, too big. So just keep going on until the end. Okay. I think we have a solution here. Man, today is cold. I can feel it in my fingers. Alright, so we need to have a DP, so we can say int DP equal, let's call it DP, new int n plus 1, okay? And then we say DP0 is equal to 0, right? And then we also need squares equal to new int 100. 101. No, 100. Right, 100. We start from 1 all the way to 100. Okay. Okay, and then we say for int I equal to 0, I smaller than. You might as well just do 101. I mean, it's fine, right? 1 smaller than qs dot length I plus plus. Actually, that's not true. That's not true. I think I shall start from 1, right? And then the end is going to be 100. Okay. Then we simply say sqs I shall equal to I times I. Oh, we can save this. Okay. Now we can say for value. Okay. Int I equal to 1. Oh, oopsie doozy. 0 is wrong. 0 shall be 1. Okay. So we say I smaller equal to n. Okay. I plus plus. We say dpi for int j equal to 1, right? J times j smaller equal to I, j plus plus. Okay. Then we say, ooh, everyone should have a giant value. Okay, so arrays dot fill dp. Okay, so what's the value on a fill? The value, well, 10 to the 4th is the maximum, so we can just go 1 2 3 4 5, right? We can go that. And then for each one we can say dpi shall equal to mass dot minimum dpi, and because each one we take 1, right? So we take 1, so it'd be 1 plus 1 plus that actually is 0. My bad, this is 0 because I have 1 here. 1 plus dp I minus j times j, right? Because I take away this, what will be the maximum? I take away the other, what will be maximum all the way to 0. So we do that. Once we're done, we get a dp, and then we blah blah blah. Once we're done, we return dpn. Okay. Let's give this a shot. Take a look. Now we can do more. 1 2 3 4 5. Okay, 100, 1000, 10,000. Run it. Yep, looks to be right. And LeetCode 279 dp solution on times 100. All right, we take a look. Yep, one shot. Let's check the previous solution. Last time I did is 2022. That's actually pretty smart. But I said it, it's the same way, right? And then we just two loops. I probably don't even need to do did I even use this? You didn't even use this. No, you did not even use this. I have no idea why you use this. Right, and then we just go two loops. Okay, yeah. I have no clue why you do that. And we're gonna correct this. This is not necessary. So we didn't even use it. Yep. That will actually be faster, I think. Yeah, a little bit faster. A little bit faster. Okay. Good. Not bad. Alright, done with this. We still haven't figured out the debugging thing yet. Some other time. Alright, let's go with a new one. I'm dying to try some new one. Although we do have a few other things that we need to take care of. Oh, a number of inverse pairs. I forgot again, man. This thing is just... K inverse pairs. I don't remember this one. Okay, strain compression. Oh, I don't remember that one either. I have a little bit memory of this. Dude, these things are just so hard for me to remember. Wait, what is this one? I've done this one, right? Apply operations to make equal to 0. I don't remember this one either. Alright, I don't remember any of these. That's gonna be tough to go back. Alright, count complete subarrays in an array. You are given an array nums consisting of positive integers. We call a subarray of an array complete if the following condition is satisfied. The number of distinct elements in the subarray is equal to the number of distinct elements in the whole array, to the number of complete subarray. Okay, complete subarray. So the number of distinct is equal to the number of distinct overall. So in this case, 1, 3, 1, 2, 2. So number of distinct overall is 3. So we want to say how many subarrays has the number of distinct equal to 3. I mean, at least we need to have 3. So we have this 3, 1, 2, right? We have this 3, 1, 2. And we have 3, 1, 2, 2. We have 1, 3, 1, 2. And of course we have 1, 3, 1, 2, 2. So yeah, 1, 2, 3, 4, and 4. Yep. Okay. 1000 in length. So we can get this one first. Then we just need to, I mean, I probably can go, because it's only 1000, which means it allows O(n) squared. So I can start with 3, just sliding window it, right? Just sliding window it. And yeah, we sliding window it, and basically we have a counter, right? Once your count is reduced, yeah, we go 3, then we go 4, then we go 5. Okay, so we can definitely sliding window it O(n) squared. Can we do better than that? Or can the mechanics be better? Or for example, when we identify the first, because if we identify like this 3, right? We identify this. This can be used as a seed, right? This is a seed, which means anything like to the left, to the right. So we can say, if I use this as a seed, right? I use this as a seed, I can have 1 on the left. So the option on the left is 1 or 2. Right, the option on the left, we have 2 options, either 0 or 1, right? So I have 2 options on the left. Oopsie doozy. And now we have 2 options on the right. So that's why the answer is this. So once we find a seed, right, we can do that. But the question is, will they be multiple seed? There might be multiple seeds, right? There might be multiple seeds. I can have a seed, and then I can keep going. Yeah, but the seed is guaranteed to be, it has to start from here or more. Must include this part. So I might have one down the line, but when we do this, we might have duplicates. So maybe, I don't know. But I feel like O(n) squared is probably not the ideal way to go with this. Or we go like one direction. How about that? Can we go one direction? Can we go one direction? We only go right. Okay? So we start from something and we only go right. So we start from something and then we keep moving, right? And then we find the first. Okay? And then we get all of them. And then we move forward. Right? We move forward. So something like this. We start from 1. Okay? I move to this one, move to this one. And this is the first time I get 3. So when that happens, I can record 2. Because it can be this or this. I record 2. And then it's done. From here, we're done. So we move this here. Is it still? It is. So we add another 2. Right? And now we move forward. This is not. So I move forward. Oh, that seems to be a viable way. Basically, we are asking, starting from a certain position, okay, how many subarrays can we get? Because all the subarrays must start from a certain position, right? Either start at the front, either start somewhere. So we're asking, starting from this position, how many subarrays can we create? And we are answering that question by that. And I think with this, we can run this in O(n) time instead of O(n) squared time. Well, I'm pretty sure we need to, we have to do a map, right? I think we have to do a map. And we need to delete map. I actually forgot how to delete items from a map. I forgot how to delete from a map in Java. But anyway, we're rolling with it. We're rolling with it. How do I delete key from map? Remove. There's a remove function. Map.remove. Okay. Thank you very much. We have map.remove. And we will use map.remove. Ooh, what did you do, man? You didn't copy everything. That was stupid. Alright, so we need a counter. So we say map integer. Okay. Counter equals new hash map. What the hell? See, I hate this the most. I absolutely destroyed everything. Too fast. I need to delete everything. Alright, so new hash map. Okay. And then, oh, how many unique values in the total? Can we say int unique count shall equal to new set? Nope. Oh my god, this is ridiculous. Command Z doesn't work, but if we do undo, it undo everything. It's like everything is considered as one chunk. I need to figure out how undo can be set up. This is ridiculous. This is ridiculous. All right, so probably is a new hash set. Hash set. Can I put? Jesus. You look, did you see that? Did you see that? This is ridiculous. I have fat fingers. Can I do nums here? Does this work? Okay, I actually have no idea. Let's JShell this. We can say one, two, three. 1, 2, 2. Okay, 1, 2, 2 is good. Okay, that's full. Can I say new hash set full? No, new hash set integer full. Is that allowed? Damn, it's not allowed. Hold on, how do I instantiate? Instantiate hash set. By construction. Ugh. Ugh, that's not what I want. That's not what I want at all. Ah, that's alright. That's alright. Yeah, there's no way, I guess. Okay. Alright, that's fine, that's fine. We can just say because I need to know the unique count. Alright, we can just say set integer uniques, okay, equal to new hash set, and for int n of nums we can do uniques dot add n. Okay, that's about it. I don't need this. Okay, I don't need this. And then I need the counter, and then we are going to do the sliding window. Okay. Why you do this, Jimbo? Why? Alright, where am I? We are doing the... Okay, so I need a J, okay? And we're gonna go... Who stayed behind? Okay, how about I stay behind? I like I stay behind. Okay, I stay behind. Then we just say for int j is equal to 0, j smaller than nums dot length. This is the right, okay? J plus plus, okay? And we also need a result. So let's do res equal to 0. All right. So what we need to do is if I need to count, right? I need to count. So if the counter's size is smaller or equal to unique size, I add whatever the j is and I move forward. Otherwise, okay, so it should be this while I is smaller than j, right? While I is smaller equal to j. Because I'm gonna shrink, right? I'll shrink until a point. Yeah, I think it's I is smaller equal to j. So while I smaller equal to j, and counter dot size, do I have a size, is equal to uniques dot size, right? If the two are the same, then I can shrink, right? I can shrink. Okay, so how are you going to shrink? I'll shrink by doing this. I'll say counter, right? Actually, I shall do this. Let's do larger equal to, just to be sure. Well, but it won't be larger equal to, right? But eventually we'll get out when it's smaller. You know what? I don't like it. I'll just do equal to. All right, so counter dot put, right? Counter dot get what? Get nums I, okay, -1. Hold on, that's not the syntax. So put nums I, and then this, right? After that, we can check if counter dot get nums I is, hold on, equal to 0, then we say counter dot remove nums I. Okay, so we do that, go back up, I plus plus, right? And then this one will go back up. The size is equal to, we try it again until it gets out. Okay, so now the size is smaller, right? Now the size is smaller, and each time, right, each time when this hits, I need to update res plus equal to update from j towards the end, right? So that shall be nums dot length minus j, right? 0 1 2, so 3 minus 1 is 2. Yeah, I think this is right. So res will update, okay, and then blah blah blah. Once we shrink, once we move forward, then we just need to move j forward, which is counter dot put nums j, okay, and wait, hold on, hash map, how do you don't have this put? It's a hash map, right? No information available. That is bonkers. No signature help. Hash map. You're telling me I do counter dot get or put integer and key, right? How come I do shift K? Now I get it. All right, this is weird. This is weird. Why this put doesn't show me anything? Because I put something in there so it doesn't show me. Okay. Counter dot put. Can I ask? Now I can ask. Right, so I say, okay, I ask for the thing which is nums I. Okay, now I go back here. Okay. It's weird, right? Earlier I was trying and it didn't work at all. It didn't work at all earlier. I have no idea. No clue at all. So, but anyway, this is gonna be counter dot get all default nums I, and this will be 0 plus 1. Okay, then we'll move the, actually that's not I, dude, this is J. This one shall be J. Alright, because J is moving forward. And at the end, we are going to return the result. Okay. Alright, let's give this a shot. Is this correct? That is bonkers. It is not correct. Okay. That is fine. We figure out where the issue is. So apparently I move all the way here. I think that's when, because counter size is now good, and now we keep going, and then eventually this gets good, right? And I get 2, and then dot put nums I should be this one, and this minus 1, right? I think that's correct. And if it's not equal to 0, this I plus plus, so I now pointed to 3, right? We come again, so this shall add again. All right, so we need to figure it out. But I haven't set up the debugger. Oh, I need to set up the debugger. Well, we don't have the debugger set up right now, but there is something we can do, because we still have IntelliJ. So basically, here's what we're gonna do. We're gonna IntelliJ it just to use its debugger. That's it. That's all we want to do. So we're gonna just put it here and run the debugger. But before we run the debugger, we probably need to change this to count. Oh, and a test cases too. So this shall be nums, and this shall be 1 3 1 2 2. Okay, don't do this. And then we're gonna do nums. Okay. Oh, shoot, that's not string. Dear me. This shall be int. Right, this shall be new int. What the hell? Wait. Oh. I tapped the wrong key. I had a capital lock. That was bonkers as well. So this one shall be this. All right, now you're happy, right? Now you're happy. A reset here. Run the debugger. All right, so we start from here. I think it's F8. Okay, F8. Put it in. Okay, so counter size is 1. What is uniques? Unique size is 3, so we don't do it. 3, 4. Okay, now I is equal to, j is equal to 4. 0, 1, 2. 0, 1, 2, 3, 4. J is equal to 4. Oh, that is the problem. That is the problem. I know what the problem is. I think the problem is I shall put it in first. That's the whole logic. That's the whole logic. We just need to put it first. Use sliding window. And for each window that contains the same number of unique values as the total array, we count the number of subarrays starting from the current start of the sliding window. And this one shall run on. Alright, let's give it a shot. And it's correct. Yeah. Good. It's a good sliding window problem. Alright, that shall be it for today. No intention to do another one because I need to shower. Alright, good. And moving on. Alright, that will be it. I will see you guys tomorrow. Adios.